Let us explore how factoring helps to solve real-life questions. The question here is, a square field has 5 meter added to its length and 2 meter added to its width. The field then had area of 130 meters square. Find the length of a side of the original field. Okay, so let's first sketch it. It's always a good practice to sketch and then write down the answer or find the solution. So now this is, let us say, a square field, right? Now what we have done here is a square field has 5 meter added to length. Let's say this is length. Let's add 5 meters to it. It becomes longer. And 2 meters added to its width. So the width is increased by 2 meters, so it becomes wider, right? So it becomes kind of a rectangle. So let me just draw a rectangle which is extra 2 meters wide and 5 meter long, right? So we get a rectangle which I'm like extending my square field and making it as a rectangle here. Now it says that this particular rectangle, then the field has an area of 130 meters square. So this rectangle has an area of 130 meters square. Find the original length, right? So we can start by defining our original square first. So it says, say, let the square field has length of x meters, right? So normally whenever it says find the length of the square field, so that is what you want to find. So we'll put meters as unit in the brackets. Define a variable which gives you what you need to find. So we get x here and x here, so that is what your original field is. Now what really happened was the square field has 5 meter added to its length. So now we have, this is 5, right? And that is 2. So we get a rectangle whose length now is x plus 5 and the width is x plus 2, correct? So that is the rectangle. So what is the area of rectangle? We know the area of rectangle is 130 meters square. Now we can write down area equals to length times width, and in our case length of the rectangle is actually x plus 5 and the width is x plus 2. So that is the area, and this area is given to us as 130 meters square. So we can equate this to 130. Now we have one variable here. We can always solve one variable from one equation. So let's apply the distributive property and then evaluate the value of x. So first in, first out. So we can do FOIL. So we'll do FOIL and then we can write down x times x is x squared. So let me write down here x squared, and x times 2 will be 2x. 5 times x will give us 5x, and 5 times 2 gives us 10 equals to 130. Now we can bring all the numbers to the left side and then get a quadratic equation. X squared, 2x plus 5x is 7x, and then we have 10 minus 130 equals to 0, correct? So we get x squared plus 7x, and 10 minus 130 is 120 with a minus sign. So at this stage we can factor this and find the answer. You can at times use quadratic formula also, right? Now you are looking for two numbers whose product should be 120 and whose sum should be 7. So what are those two numbers? To find the answer, what we should do is factor 120. So factors of 120 are, so we'll write it on the side and try to figure out what those two numbers are. So 120, and we're trying to factor 120 so that we get a combination in which when you add you get 7. Do you understand? That is the whole idea. So 120 could be written as 60 times 2, but that is too far away. 40 times 3 is also further away. So the two numbers are very close by, right? So maybe 12 times 10, No, that doesn't work. So 12 times 10 gives you 120, but does not give you. So we'll write one factor as 12 times 10. Now that does give you 120, but really does not give you the answer. So 12 could be written as 4 times 3, and 10 could be written as 5 times 2. So we get some set of numbers to work with, right? So how do you get 7 as the sum and product as minus 120 from here? So you get 4 times 5 is 20, 3 times 2 is 6. That also doesn't work. So you can have 4 times 2 as 8 and 5 times 3 as 15. Now, will that work? 8 and 15 with different signs. That does work. Do you see that? So if you combine 5 and 3, so let me just show you here. 5 and 3, and then you combine 4 times 2, 8, right? 8 and 5 and 3 gives you 15, right? So since you need positive 7, we have to have opposite signs. So we can split this. So we have two numbers here, and the numbers are 8 and 15. 15 has to be positive, and therefore we can write our solution here kind of. We can factor this and write this as x plus 15 times x minus 8 equals to 0. I hope you understand the strategy which I have used, right? So we factored this to figure out what two numbers could give us 120 as a product and sum of 7, right? It was really difficult to figure out otherwise. So we made a factored prime, kind of factored it out so that we know which numbers to play with and get our answer. So we do it like this. I hope you understand the strategy. This is a very, very important strategy to understand. Now, from here we get two solutions. So one solution is that x equals to minus 15, and the other one is that x equals to 8. Of course, we cannot have negative answers for our geometrical shapes. Dimensions are always positive. So the only answer which is a valid answer for us is x equals to 8. Do you see that? So now x equals to 8 is our valid answer. So if x is 8, then the square is 8 by 8. Do you understand? The question is find the length of side of original field, and therefore we can write down our answer. In a word problem, you have to write down answer very clearly. You say length of a side of the original field is 8, don't forget the units, meters. Do you understand? 8 meters. So that becomes your answer, 8 meters. You can always check. A good check here is 8 plus 5 is 13 and 8 plus 2 is 10. So you get 8 plus 5 is 13, right? So you get 13 times 10, which is indeed 130, correct? So that is the check. So whenever you get, there could be an error in our calculation. So it's a good check. So that is the check. Now let's review how we did the question. Read the problem carefully, define your variables. Once you define your variables, then try to make a neat sketch, label it properly. So 5 meters added to its length, that's clearly written here. 2 meters added to its width, that is the 2 meters extension of the width, right? And then write down the formulas. Formula in this case is area of the rectangle, which is length times width. At this stage, we have single variable equation in one variable. It could be solved very easily. We adopted factoring techniques to solve a trinomial, which was x squared plus 7x minus 120 equals to 0. Now, you have to consider only valid answers. X equals to minus 15 is not valid, right? So this one is not valid. Therefore, we stuck with x equals to 8, and that gives us a possible solution. Once you find the solution, check it out. You can check by placing 8 here. 8 plus 5, 13. So that is my 13. And 8 plus 2 is 10. The width of extended rectangle is 10. When you multiply, you do get 130 meters square, so it fulfills the condition we started with. Then clearly write down your answer including units. That is how you should be solving word problems. Thank you and all the best. So we missed n here, so let me do it.